Okay, this is the review for the probability quiz on Friday. We need to know some of the vocabulary for dealing with probability. We're going to talk first about the two types of probability, experimental probability and theoretical probability. Experimental probability is the probability found from experiment results. This would be, for example, the fact that there were 4 defective baseballs out of 180 baseballs manufactured. Experimental probability, something that actually happened. Theoretical probability. Theoretical probability is, in theory, this will happen because events are equally likely. Some examples might be flipping a coin, rolling a die, then we talked about compound events. And in compound events, we have 2 types of probability. We have events that are independent of each other and events that are dependent upon each other. If they are independent, one choice does not affect or effect the second choice. This would be an event where there is replacement. Dependent events, well, independent and dependent are antonyms, so dependent events would be where one choice does affect the second choice. In this situation, there is no replacement. Okay? In independent and dependent events, we multiply the probabilities. Let's look at some examples here. My spinner got moved. Move him back over here. We're going to talk about odds before we go into a probability review. Remember, the odds, what we want compared to what we don't want. Odds in favor should be of an even number. How many even numbers do I have in the spinner? I have 2, I have 2. It's not working. I have 2, 4, 6. So I have 3 even numbers. What I don't want is an odd number. I have 1, 2, 3 odd numbers. So the odds in favor of an even number is 3 to 3, or that can simplify to 1 to 1. Odds against a number less than 5. So I don't want a number less than 5. So how many are 5 or greater? Well, let's start with what we want, odds against a number less than 5. Here's 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 a number less than 5. 4 to 2. 4 are less than 5. 2 are not. Or you could say 2 to 4 in favor of a number greater than 5. 2 to 4, 4 to 2 simplifies to 2 to 1. Odds for a composite number. What is a composite number? Composite number is a number that has more than 2 factors. In other words, it's not prime. What numbers on my spinner are not prime? 1 is prime, 2 is prime, 3 is prime, 4 is not prime, 5 is prime, 6 is not prime. So 2 are composite, meaning 4 are not. So 2 to 4 can simplify again 1 to 2. Let's move on to probability. You have a pair of dice. Find the following probabilities. We're going to roll each die separately. This is the probability of rolling a 6, then an even number. What is the chance of rolling a 6? 1 6, there's 6 total, so we have a 1 in 6 chance. What is the chance of rolling an even number? Well, I have a 2, a 4, 6. There's 3 that are even. So 3 even numbers out of 6. I multiply those together and I get 3 out of 36. Multiply 6 times 6. It's not 6 plus 6. So 3 out of 36. That can simplify. You can divide those both by 3, then I get 1 in 12 chance. The probability of rolling a 1, then a 2. What is the chance that I will roll a 1? There's only 1 1, and there's 6 numbers. What is the chance that I will then roll a 2? There's only 1 2, and there's 6 numbers. So the chance of rolling a 1, then a 2, 1 times 1 is 1, 6 times 6 is 36 in simplest form. So I have a 1 in 36 chance that I will roll a 1, then a 2. What is the probability of rolling an odd number, then a multiple of 6? Odd numbers, 1, 3, 5. There's 3 odd numbers out of 6 times my second rule, which is going to be a multiple of 6. How many multiples of 6 do I have on the die? Only 1, and that is 6 out of 6. 3 times 1 is 3. 6 times 6 is 36. I can still simplify by 3, and I get 1 out of 12. So a 1 in 12 chance that I will roll an odd number and then a multiple of 6. Independent versus dependent events. Some reasoning here. You are randomly selecting a sock from your drawer, one sock. And then you randomly select another sock from your drawer. Are these independent or dependent events? Well, once you select your socks from your drawer, one of them, that's the one you're going to wear. Then you're going to reach back in and select another one. Replacement or no replacement? No replacement. Since there is no replacement, these are dependent events. It's a dependent event because you have one less sock in your drawer after you draw the first one to put on. Moving along, suppose that you're going to toss a coin 4 times. What is the probability that you will get heads each time? What is the chance that I'll get heads the first time? It's a 1 in 2 chance. What's the chance I'm going to get heads the second time? 1 in 2 chance. What's the chance the third time? A 1 out of 2. And the fourth time again, 1 out of 2. Multiplying all those together, 1 times 1 times 1 times 1 is 1. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. I have a 1 in 16 chance that if I flip a coin 4 times in a row, all of them will be heads. Independent or dependent? They're independent. The first flip doesn't matter about the second flip. I still have the same chance. An astronomer calculates that the probability that a visible meteor shower will occur in May is 3 out of 14. What is the probability that a visible meteor shower will not, keyword, occur in May? Well, if there's a 3 out of 14 chance it will, that means how many out of 14 that it will not? 14 minus 3 is 11. So there's 11 in 14 chance that it will not be visible in May. I have 2 quarters, 5 dimes, and 7 pennies in my wallet. I need to find the 5 following probabilities: that I will grab a quarter, and then I will grab another quarter, key here, without replacing. Okay? How many coins do I have in my purse? 2 quarters, 5 dimes, 7 pennies. 7 plus 5 is 12, plus 2 is 14. So I'm going to grab a quarter. I have a 2 out of 14 chance that I will get a quarter. I'm not replacing, so I'm going to grab another quarter. I already took 1, so that means there's only 1 left. 1 out of, I already took a coin, so now there's only 13 left. 2 14ths will simplify to 1/7. Multiply those together, I get 1. 7 times 3 is 21. 2. 91. A 1 in 91 chance that I will get a quarter and then another quarter without replacing. Grabbing a penny and a dime with replacing. Okay? The chance that I'm going to grab a penny, 7 pennies out of 14 times, I'm replacing. So again, I have 14 coins. A dime. I have 5 dimes. I'm going to simplify this to 1/2. Therefore, I have a 5 in 28 chance that I will draw a penny and then a dime if I'm replacing. This time I'm going to be grabbing 3 dimes without replacing. The chance I'm going to get a dime is 5 out of 14. The chance that I'm going to get a dime the second time, remember I didn't replace, so now I only have 4 dimes, and I have 13 coins. The chance that I'm going to get a dime the third time, I've already got 2 dimes, which means I have 3 dimes left out of 12. Let's do some simplifying. 3 and 12 would be 1/4, 2 sevenths. 5 times 2 is 10. 10 times 1 is 10. 7 times 4 is 28. 28 times 13. $364. Simplify by 2, and I get 5/182. A 5 in 182 chance that I will get 3 dimes in a row without replacing. We need to select 3 8th grade students. There are 40 boys and 30 girls for a conference. Find the probability of 3 girls being chosen in a row. All 3 that we're going to select are going to be girls. Well, there's 30 girls out of 70 students. Times, am I going to be replacing or not replacing? Once a student is chosen, they've been chosen. So these are going to be dependent events. Now, instead of 30 girls, I have 29. Instead of 70, I have 69. For the third girl, instead of 29, I now have 28. Instead of 69, I now have 68. We can do some simplifying here. So now I have 29 times 2. Actually, I can probably go one more time here. 29 over 17 times 23. 391. So a 29 out of 391 chance. What's the chance that I will select 3 boys? Well, how many boys are there? There's 40 boys out of 70. You've selected a boy, so now there's 39 out of 69. And I selected another boy, so now there's 38 out of 68. Now that I've helped you set these up, I'm going to have you work to finish the last 2. When you play Scrabble for the last problem, you choose letters. Once you choose a letter, it's your letter to use in the game. So you decide, are these events going to be dependent or independent? Goodbye, Stormy.